as I was explaining, let's say that this force here, let's say we have a force like this. Okay, let's say we have an object on a horizontal. So this object is applied at an angle like that, at an angle theta. Then, guys, the difference on this object, normal force is not equal to Fg. Why? The reason that we said normal force is equal to Fg, we said this is F net, it's equal to ma. So this a horizontal component, the acceleration is 0. So F net is equal to 0. Therefore, we take up as positive, which is the normal force. We minus all the forces that are going down, which is Fg. We equate this to 0. Therefore, F net is equal to Fg. So when it is like that, normal force will be equal to Fg. But when the force is applied at an angle, first thing first, we're going to indicate all the forces that are acting on this object. So if we indicate all the forces acting on an object are like this. Right. So now I need someone in this session to tell me the other force, the other vertical force. Can someone please tell me what is the other third force that we have, the vertical force? Anyone? That we have on this object. Anyone, guys? Okay. I'm asking that. Remember, we have the normal force and the Fg, the gravitational force. So I'm asking that there is a third force that is vertical. I need you guys to give me the vertical force. Which one?
Fy.
Exactly, the Fy. So I'm going to go back to this and say that I know that if you say this is Fy, so let's indicate where is that Fy. Remember, Fy will go in the same direction as what? The Fy will go in the same direction as our applied force. Remember, this is F applied. I'm sorry. So now, this is our Fy. Then you're going to draw a free body diagram indicating all the forces that are acting on this object. So I'm going to have this as Fg. Then we have the other force, which is the Fy going up. So when we do F net, we know that F net is equal to 0. So we choose direction up as positive. Then I'm going to say the normal force, which is up, I'm going to add it with Fy. Then we subtract all the forces that are going down, equate that to 0. So when I have something like that, what I'm going to do is that I need to find the normal force. I need to make the normal force subject of the formula. So the Fg will come this side to be positive and the Fy will come to be negative. So now, guys, let's quickly go back to what we discussed. Okay, so we know that we haven't talked about the Fg, but I'm just gonna write it down because so far I think everyone understands how to find the Fg. Right, we know that this Fn, the normal force will be Fg, so which is mg is the weight, then minus Fy. What is Fy equal to? Can someone tell us what is the what is the Fy, which is the perpendicular component? What is that equals to? Can someone please tell us? Do you guys know what is Fy? Titelo, do you know what is Fy equals to?
It's F sine theta.
It's F, the sine of theta. Thank you very much. That's very correct. So it's Fy will be F, the sine of theta. So this is how you do what? This is how you find the normal force if the angle is applied, and then if the force is applied at an angle. Do you guys understand? So to put this thing, if the angle is applied, if the force is applied at an angle, this is the normal force. So if the angle is pushed. If the force is pushed like this at an angle, the normal force will be different. So the normal force in this case will be what? You just have to follow all the steps that we did, because now the Fy will go down. You draw the free body diagram. This will tell you that the force will be the normal force will be F mg plus F, the sine of theta. So the difference between when the force is pulled, we say the weight minus Fy. And when the force is pushed, the normal force will be mg plus the Fy. Now, when this thing it is in an incline, when it is like this, and it is applied at an angle, in this case, remember that the normal force is what? The normal force, it will be the Fg perpendicular. So on our next session, we're going to discuss when it is pulled at an angle, while it is on what? While it is at the incline. So this is what we're going to discuss on our next level. But before we end this session, do you guys have any questions based on what we did today? Do you guys have any question based off what we've covered so far?
So I don't have a question, but I heard you speak something of a group, but I'm not on it.
Oh, yes, please, they can send us your number, then we'll add you on the group.
Okay, so no problem.
Yeah, if you are not on the group, please forward your number, then I'll add you to the group, no problem. Are you all happy?
Yes, sir.
Okay, thank you guys. I'll see you. I think we have a session on Wednesday. I'm not sure if it's maths or if it's physics. It's fine. I'll confirm. Thank you very much for joining the session. I'll see you on our next session, and have a great evening.
Thank you, sir.
Bye.